Today we're talking about section 4-5 on the multiplication rule. In particular, we will be emphasizing the complements and conditional probability. So at the end of this section, you'll be able to calculate the probability of at least one using the complements rule. And number two, calculate the conditional probability of event B given that event A has occurred. So, complements, the probability of at least one. At least one means one or more. At least one means one or more. The complement of at least one is none. Okay. Complement of at least one is none. To find the probability of at least one of something, calculate the probability of none, then subtract that result from 1. That is, the probability of at least one equals 1 minus the probability of none. So, in example 1, we're asked to find the probability of getting at least one boy in a family of 3 children. So that would be the probability of at least one boy is equal to 1 minus the probability of no boys. So probability of no boys means that we have 3 girls. Well, the probability of the first girl is 1/2. Probability of the second child being a girl is 1/2. And the probability of the third child being a girl is 1/2. So if we multiply those together, we get 1/8. So our probability in this case, the probability of at least one boy, would be 1 minus that 1/8 we just found. So our answer is 7/8. Alright, so suppose you toss 4 fair coins. What is the probability that you get at least one heads? Take a moment to think about that. Alright, so the probability of at least one heads equals 1 minus the probability of no heads. So we're tossing 4 coins. That means that we have to get tails, 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 tails. No head means all tails. And the probability of getting tails on the first toss is 1/2, on the second 1/2, on the third 1/2, and on the fourth 1/2. So we get 1/16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 1 minus 1/16. Remember that 1 is 16/16. So we're subtracting 1/16 from 16/16. We get 15/16. Okay. Our next part is taking a look at what we mean by conditional probability. And the way we read this is the probability of B given A. So we're calculating the probability of B given that A, the event A, has already occurred. Now, intuitive approach says the conditional probability of B given A can be found by assuming that event A has occurred and working under that assumption calculating the probability that event B will occur. So let's look at example 1. Suppose you are drawing 2 cards from the deck of 52 cards without replacement. And those are words you have to look for. Very important here. So when we remove a card, our probabilities are going to change as we go to draw the second card. Okay, what is the probability you will draw a king on the second card given that you have drawn a 5 on the first card? Alright, so since you have removed 5 from the deck on the first draw, that means that there are 51 cards remaining, of which 4 are kings. So a probability of getting a king on the second draw would be 4 out of 51. So if you're looking at the probability of getting a 5 on the first draw, and that means we're going to be multiplying, and a king on the second draw, probability of a 5 on the first draw, we've removed a 5. So probability of king on the second draw, we still have 4 kings out of the 51 remaining cards. And then we multiply and reduce, or reduce and multiply. All right, let's take a look on example 2. Suppose you have a bag containing 5 red marbles, 8 blue marbles, 7 yellow marbles, and you're drawing 2 marbles from the bag, again without, again keywords, without replacement. What is the probability you get a marble on the second draw, given that you got a marble, a red marble on the first draw? So we're talking about probability red on second given red on first. So we're just looking at the second draw, but we know we removed a red marble on the first draw. Okay, so we started out, we have 5 plus 8 plus 7, that would be 5 plus 15. We have a total of 20 marbles. And we started out with 5 red. So we've removed a red, that's going to bring this number down to 19, and this number here down to 4. So that means the probability of red on the second draw, knowing that we've removed a red marble, would be 4 out of 19. Okay, and so we want to know the probability of getting red and red. So this is the first draw and the second draw. So red on the first draw, we have 5 out of the 20. We assume, because of the fact that we're doing an and situation, we want to assume that a red has been drawn on the first draw. So on the second draw, there's only 4 reds left out of the 19 marbles. And 5 times 4 is 20. So we're going to get 1 over 19 as a probability. And you'll notice that I like to reduce before I do the multiplication. Okay, now we're going to use a table from the textbook, and this table is found on page 170 in the book. It's also found, I believe it's the same one that's found on page 165 in the exercises, and also as part of the chapter problem before section 4-1. So you have several places. It's at the bottom of page 133 as well. So once you locate one of those places for the table, we're asked to find some different conditional probabilities. So first of all, we're asked to find the probability that the result is negative given that the subject uses drugs. So what we want to do is focus our attention only on the line that says subject uses drug. So this tells us where to focus. We're not looking at anything else. As we look on that row, there are 44 true positive and 6 false negative. So that's a total of 50 people who use drugs. So this gives us the denominator. The condition that's given gives us the denominator. So in this case, we're looking at that particular row, adding up all the ones that use drugs. We have 50 people who use drugs. Now, how many got a negative test result out of that group? Well, looking at the table, it's 6, and we can reduce this to 3 over 25. Okay, so let's look at the second one. The next one, we want to find the probability a subject uses drugs given that we have a positive test result. So this time we're looking at the column under positive test result. That's going to give us our denominator. So looking at that column, I have to add up 44 plus 90. That would be 134. Had a positive test result. So I know that's my denominator. Now in that column, I want to know how many used drugs. 44 of them. So let's see, I know I can reduce by 2. So I get 22 out of 67. Alright, so now I'm down to my third one that I want to do. Again, I want to focus initially on the given subject does not use drugs. So I look at this time I'm in the second row. The second row includes everyone who did not use drugs. And there are 90 plus 860. That gives us 950. So again, that is our denominator. That given, whatever condition we're given, focuses our attention on only a portion of the table, a row or a column. In this case, it's the row for which the subject does not use drugs. And how many have positives out of that row? 90. Okay, so we end up with 9/95.